This video is going to show how to access the Module 1 material and discuss Section A from Module 1. So once you are out at the MindTap website, you should see Module 1 digital content. Remember that that is a toggle. On my view, it is turned off because you can't see it yet. But once you can see it, you just toggle down, find the reading and resources, and click on the Module 1 digital content reading material. And that will open up the ebook for you. And you should see this screen, which in a traditional textbook would look like the very first page of the module. So you can see that there's a module introduction where we'll start in just a second. And then there are 5 sections, as well as some end of the chapter material. So in the last introduction section, we just kind of had what was the equivalent of Section A. But you can see that this chapter, again, has 5 sections, and they're pretty long. So I'm going to attempt to make one video for probably just one section, maybe one video for 2 sections. This is my first one, so we'll see how long this one goes. So let's go ahead and get started. I'm just going to click on Module Introduction to get us started on the introduction page. Most of the chapters, which again they're calling modules, have this introduction page, and it's just going to, introduce you to what they're going to talk about. I'm not going to read all of this stuff. They do have a little pre-check, an interactive pre-check if you want to go through that. That is optional. So I'm going to click on this next page button to start us on Section A, which is called Digital Basics. And sort of like the introduction page for the entire module, each section page also has a little mini introduction page to the section itself. So they're using these like mind map things here to kind of show you some of the things that they're talking about, just a brief overview, and then some lesson objectives, and then the terminology. Now you may recall from the introduction module that most of these were not clickable links because I mentioned they had a mess up there, but beginning in Module 1, all of these terms are interactive, and so you can click on them to get a description of what they mean, and then they are embedded throughout the section as well, and they are clickable links throughout the reading material also. But these are all the new terms that you'll see in this section. So let's go ahead and get started with Section A. So I did decide to, for right now anyway, not do PowerPoints. I have found that when I go through PowerPoints with students, they tend to not look at the chapter material. And so I thought I would try this, and I may ask you for some feedback just to see how well you like going through the textbook instead. So here's what I suggest. Watch this video. You may want to make it small on your screen and have your ebook open as well. And as I go through and talk about things and show you things that I've highlighted, you may want to highlight them in your textbook as well. We are not going to have any traditional exams just because this is a virtual environment, but at midterm you'll have some midterm activities, and you may want to refer back to some of these highlighted things, and so it would be a good idea for you to be highlighting as you go. So I'm not going to read the textbook to you, but I do, again, want to spend a little bit of time talking about some of the highlighted things. So first thing that we come to here on this data representation basics page is that there is a difference between the terms data and information. Usually, people refer to data as unprocessed, okay? It is something that typically goes into a computer system, whereas information is typically viewed as something useful that comes out of a computer system. So you'll see this last sentence says, data is used by machines, again, usually in the form of input, and information is used by humans. And after the computer's done its processing, then it becomes useful to us. All right, scrolling on down, they have a little discussion here about analog versus digital. So digital data is, kind of the new method. We represent a lot of things as digital data, and we say that we can store things as zeros or ones. or false and true. You will get lots more on this in the 1411 lab this week. So I'm not going to spend a lot of time talking about digital data and binary right here. Just mention it because your lab this week focuses on the binary numbering system. All right, analog, in contrast, says it is used to represent an infinite scale of values. I love the example that they give here. A dimmer switch, to control a light switch is used here to represent analog, and an on or off light switch is representative of binary. So it's a very good description. Let's see, don't forget that these quick checks are embedded here so that you can, I'm just going to randomly click one and it'll show you what the correct answer is. So after you've read the material, you can use these little quick checks, which are not graded. These are optional to kind of check your understanding. All right, so here it mentions that zeros and ones are referred to as binary digits, or bit for short. Again, more on that in the lab. But there are lots of different ways that you can represent digital data. And we'll talk about a few of these as we go through the chapter. But they're not all traditional zeros and ones. Circuit boards, for example, those use different pulses. CDs and DVDs use light spots and dark spots. Disk drives use magnetized particles. But the key figure or takeaway here is that it's two states, okay, typically on or off, positive, negative, those types of things. And at the very bottom of this page, just a brief mention of digital data is stored in files, and every file has a type, okay? And how do we know what type it is? We look at the file name extension, such as here they're looking at .mp3. Which is a music file. And so this is what tells the operating system, this file extension tells the operating system what program to use to open your file with. And so it's a very useful thing. You can't go just changing file systems or file formats, because it will mess up. It may mess up the file, and your computer is going to be confused as far as what to use to open that particular file. All right, moving on to the next page. So here we're going to look at representing numbers. Interesting thing at the top, not all numbers are considered numerical data. Things like social security numbers and telephone numbers, you don't do any mathematical calculations with those. You may sort them, but you're not going to do any math. And so those are typically not represented as numerical data. Those are typically textual data. So again, here is a mention of the binary numbering system. It does only use two digits, 0 and 1. And again, lots more on that in the 1411 lab this week, so I'm not going to really talk about that here. You can read this brief introduction, which will give you a really good start to the lab for this week. Okay, we also represent text with digital data. And so character data, or just text, is typically what we refer to as letters, symbols, and numbers that are not used in calculations, like the phone numbers and the social security numbers that we just mentioned. So how do digital devices represent text? Well, let's back up for a second, because we just talked about representing numbers, and the binary numbering system, or side note, there are actually other numbering systems as well. Those are used to represent numbers, but to represent text, there are different types of codes that we can use. Some of the common ones mentioned here are ASCII, extended ASCII, Unicode, UTF-8, and they all basically just have a lookup system as far as this is the code that represents this particular character. And so you would not want to have to memorize all of those. I used to make my students write their name using ASCII, and then we would, in the classroom, we would trade papers, and you would have to decode. So first you had to encode your name, and then someone else would decode your name. And it was a pretty fun activity, and they really appreciated the proofreading skills, because if you just got one number out of place, it threw your entire name off. Let's see. Interesting to note that ASCII files do not contain formatting. So many times they are saved and referred to as plain text. So you can't have any bold or italics or anything like that in those documents. They're very useful for basic word processors. If you want to have those kinds of styles and formatting, what happens is the word processor that you're using has to embed formatting codes in your text. And of course, there are special codes for that in those different systems. And I'm just scrolling along here to see what else I highlighted, and I don't see anything else on that page, so I'm going to try to hurry because I'm already at 10 minutes on this video. All right, bits and bytes. Terminology related to bits and bytes is used to describe things like storage capacity and network access speed. So a bit is one digit, a 0 or a 1, but a group of those 8 bits is called a byte. And that is typically our basis for, again, storage capacities and network access speeds. So you've probably seen a table similar to this before where it talks about different quantities. So like kilobyte, for example, I don't know if it'll let me highlight this. Oh, it will. So that is, 2 to the 10th power, which is actually 1,024. So it's interesting to note that the prefix kilo means 1,000. And here we see that a kilobyte is exactly 1,024. So not 1,000, it's 1,024 because we're dealing with powers of 2. So that's a little bit confusing to some people, and there is a movement to sort of correct that, but it hasn't really taken off yet. So we just say about 1,000. A kilobyte is about 1,000 bytes. A megabyte is about 1,000,000 bytes. A gigabyte is about 1,000,000,000 bytes, and so forth. And you just keep adding powers of 10 on there. And that's sort of explained right there. So just as a general rule, we typically use bits for data rates. So your internet connection speed at your house may be something like 50 megabits per second, and we say megabits per second there. Whereas if you're looking at storage capacities, we might say that you have a 500 gigabyte hard drive or a 1 terabyte hard drive, and we use bytes when we're talking about those storage capacities. All right, data compression. You'll notice here there's some embedded videos. I can't remember if we've seen those yet. These are typically very short. I'm just going to click on play. I'm not going to play the whole thing for you, but just to show you that it will play, it should play right there in your window. You can go to full screen if you would like to do that, but these are typically just useful little videos that are pertinent to the information that they're talking about. So you've got a couple there on how to compress a file in Windows and how to extract files in Windows. 2 very useful things if you don't know how to do that. So in talking about data compression, it tells us here that it refers to any technique that recodes the data in a file so that it contains fewer bits. If you are working at home on a slow internet speed, you know that it takes a long time for things to upload and download. And so if you're having to transmit a lot of things, it might be useful to you to compress the file or a group of files together in a folder by using a zipping or a compression method, because it will upload and or send quicker. And so a lot of people use that. They do refer to 2 different types of compression techniques here. Lossless does not lose any data, and so it's very important if you're dealing with character data or numeric data that you don't lose any of that data. It needs to stay as is. Lossy compression, though, is where a little bit of the quality is lost for like music files or images or videos. And the human eye and ear typically cannot discern those changes, that little bit of loss of quality, and so it's worth it to have smaller file sizes there. Again, the how-to, that you can watch that in those videos. If you get a file that is zipped or compressed, then you have to unzip it or uncompress it before you can view it. And again, that's explained in the video at the top. And that concludes section A, so the next video will start with section B.